right, we've got another scenario here. We have this 13-foot ladder, which you'll often find in a math textbook, but they're hard to come by in hardware stores. This 13-foot ladder is leaning up against a wall here. And Harold is doing something that I don't recommend. He's standing under the ladder. Now Maude is going to do something else that I also don't recommend. She's going to walk by and she's going to kick the ladder so that the base of the ladder is going to be moving away from the wall. And as that happens, the top of the ladder is going to be sliding down the wall. Now that's not a very nice thing. Maude's going to move out of the way so that the ladder doesn't trip her. But Harold, poor Harold, is sort of frozen in fear. So he doesn't manage to get away. He's going to duck. So we're told Harold ducks, but the ladder still hits him when it's 5 feet off the ground. It's going to conk him on the head. It's a very sad story, isn't it? Okay. At that moment, the top of the ladder is sliding down the wall at a rate of 2 feet per second. And we want to know how fast is the base of the ladder moving away from the wall at that time. I don't know why that's our concern rather than whether Harold's okay, but that's our concern. So let's see if we can't figure that out. Okay, so at every moment in time, we're going to have a triangle like so. I'm going to just call this H for the height that we are off the ground. I think I'll call this W for the distance that we are from the wall. And then this is the ladder, which is 13 feet. Okay. And the ladder sliding down the wall. So this side is going to be decreasing at a rate of 2 feet per second. And it's moving away from the wall. And we're asked to figure out what that rate is. Now, I'm not saying this is a constant rate of 2 feet per second. It might be a changing rate. As it gets further down, it's going to build up some speed and be going a little bit faster, perhaps. But that's the rate at the moment in time that we care about, which is when it conks Harold on the head. Okay, so it looks like we're going to have h squared plus w squared equals 13 squared, which is 169. Okay. Now, h and w are both changing, so they are functions of time. So each of these is a function composition. Okay. Now 169, that's not changing, but that just means it's a constant function of time. These two functions of time together always add up to that same constant number. So I'm going to take the derivative with respect to time of both sides. H squared plus w squared, and that's got to equal the derivative with respect to time of 169. Now on the left, this is chain rule. Derivative of h squared is 2h, h prime. Plus, derivative of w squared is 2w, w prime. And the derivative of a constant is just 0. Okay, so now we wanted to know how fast it's moving away from the wall. So we want to know what w prime is at this moment in time. So that means we need to plug in for h, h prime, and w. So, and actually before we do that, I'm going to just divide through by 2. So we've just got h, h prime plus w, w prime equals 0. Okay, so h, that's the height from the ground, and we're told it hits Harold when that is 5. At that moment, the ladder is sliding down the wall at a rate of 2 feet per second. Let's make sure we double check. Is h increasing or decreasing? If the ladder is sliding down the wall, h is decreasing, so that the derivative is -2. Remember, we're almost always told the absolute value of the derivative, and then there are words to indicate the direction in which things are going. We need to translate that into a plus or minus sign, depending on whether our quantity is increasing or decreasing. Okay, plus w, and let's see, I'm going to have to figure that out. At this moment in time, I've got a particular triangle where this is 13. Oh, I did not draw that at all to scale. This is 13, this is 5. This is W at that moment in time. Now, you might recognize this is a 5, 12, 13 triangle, so W is 12. If you didn't recognize that, you just use Pythagoras. W squared plus 25 equals 169. W squared is 144. And W I know is positive because it's a distance, so it would be 12. Okay, and then W prime is what we're going to solve for. So what we have then is negative 10 plus 12W prime equals 0. 12W prime equals 10. W prime equals 10 twelfths, which would reduce to 5 sixths. It makes sense that that's positive because if the ladder is sliding away from the wall, the distance to the wall is going to be increasing. Okay. I always like to do a quick double check. If I get the wrong sign in my answer, that's going to tell me that somewhere in my setup, or perhaps when I was plugging in the other derivatives, I made a mistake. Okay, let's see. We want to then answer the question in English, so we'll say the ladder is moving away from the wall at a rate of 5/6, and then let's get the units. So this was W prime, so it's going to be the units for W. That was a distance. We were measuring everything in feet, divided by the units for time, and it looks like we were measuring time in seconds because the other rate was given in feet per second. So that would be 5/6 feet per second.